Yes, good afternoon. And as far as we have been considering with respect to linear programming techniques in the operational research, today we would like to see the graphical representation related to the linear programming problems. In the yesterday's class, we have gone through a minimal example, that is Geppetto example, manufacturing of soldier toys and trains toys, and usually a maximum, how much maximum profit need to be gained, in the sense we have solved the problem in the yesterday's class as per the labor working timings, and how much investment as per the investment schedule also. Solving with respect to a linear programming involves four different cases, and these four different cases have been solved with respect to the proportionality, additivity, divisibility, and certainty concepts in the yesterday's class. And today we'll be moving this to the next phase, indeed to get the multiple cadre of results, not only in the case of linear programming mathematical relation, as they have been solved out with respect to a proportionality methodology utilizing in linear programming technology. But in the today's class, we will be processing the similar problem solvation with respect to a graphical representation by taking with respect to a values as we have got in the yesterday's mathematical relations. For this, there are four different cases need to be analyzed. First one, it is initial stage. At an initial stage, the linear programming has an unique optimal solution. So optimum in the sense, the least possible way of getting the solution in an easy format. That is an optimal solution. Second one, it is linear programming has even the multiple option of solutions also. That is nothing but utilization of actually an infinite number of solutions will be obtained by utilizing the iterative methodology of solving process. So iterative in the sense we will be taking the input values with a slight variations, and depending upon that we will be obtaining the feasible results as per our convenience, or these values obtained as per our convenience need to be exist in between the preferable limitations. So preferable limitations in the sense, as we have been discussed in the yesterday's class, that the obtained value is valid only when the obtained value is in between the acceptable values. So acceptable values in the sense, for example, we have got the solution for yesterday's Geppetto problem. That is maximum profit we have been at, that is $180. So if the result has been obtained in between 175 to 185, in the sense that is in between, whether the answer may be of 176, and even the float values also can be considered, that is 176.5, 176.25, 178, 179, etc., until 185. So the obtained value upon the experimentational process or mathematical solvation process as per the linear programming technique we have been solved is 180, and hence it is acceptable value. So like that, these values will be varying with respect to the input parameters that we have been taken. So input parameters in the sense that n value, for example, in yesterday's we have been taken the x1, y1 values. So if the variations has been or variables has been changed, automatically the obtained feasible z maximum result will be getting changed. So that value should be in between these acceptable limitations. Then the obtained value will be called as a valid representational value. So that is nothing but the multiple solutions that is obtained in optimal basis. And this linear programming is infeasible. It has no feasible solution. So there is no any perfect solution or static solution that it should be obtained only that solution like that. So feasible solutions, just we have been discussed in between the range that has been provided, it should be existed. Next one, it is linear programming is unbounded because there are certain points with arbitrary, that is nothing but large values or objective functional values, large values. So those are also need to be considered and analyzed as per the systemic or promotional calculation levels. So here, most probably, the graphical representation involves the graphical solution of Gepetto in the space problem. We have opted the we have got a solution that is only two variables can be solved. There is a representation that x value and y value need to be existed, and only these two values will be obtained nominally. All right. The graphical solution of Gepetto, as per the basis of the solved problem yesterday, we'll be having two results majorly here. There is an x value and a y value. So indeed, to obtain a two-dimensional relation, basically we need x and y values to be obtained in an analytical format, or even indeed to raise the graph, just as shown in the figure. I will be initiating the diagram here. Yeah, this is a graphical solution. So in the x-axis we will be obtaining a value, and corresponding y-axis also will be having a value depending upon the mathematical calculations that we have been done with the constrained values we have been taken in the yesterday's relations. So by obtaining those relations only, we will have both this x value and y value. If either one value has been obtained, for example, x1 value is known to us, y1 value is unknown, but the equating maximum working efficiency, that is z calculation, is equal to z calculation. And LHS side it is x1 plus y1, just like this, and this z value. So this z value is an, let us consider the RHS side, right hand side, and the x1 plus x2 will be considering in a left hand side direction. So if any one of the value, so two unknown variables, it will when it been existing in a polynomial equation, will be obtaining a other final value. In our problem that we have been obtaining, indeed to obtain the z values, we have the x1 and x2. Similarly, we are indeed to plot the graph, we need the x1 as well as x and y coordinate values. So we'll be having the equating answer, that is equating level also in the program, and one value of our h side, and any one of the value of x, let it be the y and y value. So y value will be conspiracy, need to be found, and x and z will be having the values simultaneously we can find. Correspondingly, if any another one more value has been got delayed, the remaining values can be obtained. So these are the basic formulation sources that we'll be utilizing to obtain the x and y values, and depend with the help of those values we can plot the graphical analysis. So for our convenience, we have been solved the problem related to this Gepetto problem, manufacturing of both soldier toys and trains. In the yesterday's class, we have been solved this problem. So I am taking the same values, that maximum z is equal to 3x1 plus 2x2, the objective function, and the number of working hours at the finishing constraint, that is 100 hours, and equating this both the functionalities, manufacturing of this soldier toys and the train toys, equating with respect to the 100 hours of finishing constraint. And next, carpentry work for both the axes or manufacturing of soldier and train toys is 80 hours given in the yesterday's problem. So I'm taking the similar values here, but we are having another one more constraint and demand here. That is nothing but X1 is having for a demand of only manufacturing of 40 soldier toys, but there is no any restriction related to the train toys, and hence we have been already considered the fourth relation, that is sign restrictions. So four relations that have been discussed in this class, that is first one it is proportionality limit, next one it is additivity application, next one it is divisibility application, and finally a certainty or sign values. So this is sign value representation. So signs will be in an only positive characterization, that is more than the zero. So sign restrictions, that is x1 and x2, nothing but manufacturing of both the soldiers and the trains are greater than zero, because it is clearly specifying that there is no any limitation for manufacturing of train toys, that is it may be more than 40 or greater than 0, and soldiers are limited to 40, that is x1 less than or equal to 40, right? So then taking the similar values, and we'll be seeing the graphical solution how we need to plot with respect to the existing values with us, considering a set of points, considering a points, that is that is D, G, F, E, and H. This is a dome line. See, click carefully. There is D, G, F, E, and H. Five different points, right? So five different points has been captured with and it has been obtained with a five-sided polygon. So a polygon representation has been commenced. So first side, second side, D2C, third side, fourth side, and fifth side. So polygon, regular polygon, five sides pentagon has been obtained. And here, as per the Gepetto or linear programming theoretical factors, when we have been considered it, we have to analyze that any point with the interior of the polygon obtained. So this five sides polygon we are considering, and within that polygon, if any of the point has been obtained in the calculated values that we have been calculated with respect to our formulations, so these values. So with respect to the values, then in the it is will be calculated that the values are existing in the feasible region. So nothing but just we have discussed that the range of values should be between 175 to 185. So in between those only the values has been obtaining. So hence that values are feasible, hence we will be concluding. So, having identified this feasible region for the linear programming, the search will be getting began in an optimal solution. So, optimal solution here in the sense a short length of solvation existing or simplification existing into the values, or generally shortest path that is being existing for getting a maximum feasible region with the largest z value or maximization of problem. And we are having a point here to find the solution, a line on which the points have the same value has been graphed here. See, considering a maximum stream, maximum working hours, that is 100 hours of first one it is finishing concept, and next one 80 hours, that is for 80 hours it is for carpentry work considered in the y-axis direction, and in the x-axis direction, so limited, we are also having that certainty, it should not be manufacturing of toys should not be less than zero. So hence the criteria has been satisfied, and within this prescribed time period, we are having that trains manufacturing is there is no any limit, but for the manufacturing of soldier toys we are having 40 limit. So hence the trains may be increasing to 50 or 60 or 70 or 80, that will be coming the value upon our calculations, and hence we will be plotting that. So considering the semi-axing or division process, we are having additional additivity, divisibility, and next certainty. First one, we are considering the additivity. So additivity in the sense, in the y-axis direction we have been taken that 80. Just let us consider the similar 80 products. If we have been manufactured 80 products, what will be the time consumed or time bound? As per the time bound, how many products or how many number of articles has been manufactured. Next one, it is divisibility. Divisibility concept application. If the 100 hours has been taken, so let us consider equating or dividing these 100 hours to by 2, indeed to get only 50 articles that has been manufactured. So hence correspondingly 50 has been considered. But leastly we are having only 40 products or 40 toys that is related to the soldiers manufacture. So beyond that, soldiers and the trains are not existing. So definitely the number is increasing greater than the 40. So question itself, it is clearly specifying. So the graphical analysis on applying these four different parameters as we have discussed in yesterday's class, and presently pursuing towards the graphical representation, it identifies in a similar format. So first one, it is a proportionality range. Proportionality range, we are analyzing the solution basis as per the given diagrammatical procedure and given polynomial equations and constraints we have been considered, and depending upon those constraints we will be obtaining a feasible values. And second one, it is additivity applied with respect to an x coordinate axis with respect to the y coordinate, and divisibility similarly obtaining in the case of manufacturing this finishing for the objects or toys, and next the carpentry work. So 100 hours divided by 2, and simultaneously 80 hours divided by 2, that is 40, and dotted line has been grasped here. So divisibility has been applied for both the manufacturing the toys. And fourth one, it is an certainty. So how we will justify with respect to this graphical representation, the obtained values are within the optimal limitations or not. This is the major factor need to be identified. So for that, we'll be having a consideration here. It points of z value, same z value has been graphed till now as we have discussed in the diagram. And in a maximum problems, that particular line is called iso profit line, maximum iso cost line also. So this is called maximum iso profit line 82C DC line, and iso cost line, that is B to A line, right? So considering the ISO profit lines, and for the ISO profit lines, taking the Z values as an consideration with respect to the dome or polygon that we have been taken, that is D, Z, F, E, and H. So beyond this, the input parameters has been considered with respect to the techniques applied, that is additivity and divisibility, but overleading the production as per the work time bound taken place to increase the cost effectivity also. Nothing but if the time period has been consumed more, number of articles will be increased furtherly. And yesterday we have been concluded another one more point with respect to the normal polynomial equation solving, that if number of labor has been increased, there is no need of these 100 hours or 80 hours of time for manufacturing this for entire products, that is soldier toys preparation and trains preparation. if the labor has been increased furtherly. So that is the optimal solution as per the basic proportionality variation solvation problem identification with respect to the linear programming technology application. Second one, it is in the today's problem, this graphical analysis hence specifies that ISO profit line that depending on the manufacturing of these products, whether beyond the 40, if the production has been increased, the cost line or the cost line, whether it will be increasing or not, will be analyzed. That is an ISO cost line. And next one is upon manufacturing this, the profit of shares will be getting increased or not, will be identifying further. So hence there is an ISO profit variations. So these are the graphical representation need to be plotted by getting the values upon solving the problem by taking different constraints given in the problem as just we have been solved in the yesterday's problem. Similarly, for our convenience of understanding, we'll be moving on to the second problem and we will look after the graphical representation for this problem also. Just I will do one thing. I will explain the overall this problem, second problem, and will give the formulations for calculating, right? And the plotting values here. So you just I have moved on to the third problem also here. I will be discussing that one also, but I need only one characterization that after explaining this problem, getting after getting these results, you will be having these solutions, values, and you yourself try to plot this graphical representation. Right? That is my task for you today. Right? 1 second. Second problem. That is, Sailco is a company must determine how many sailboats to produce in the next 4 quarters. So here quarter in the sense for an entire year, 1 year has been subclassified into a half in the sense 6 months, quarter in the sense 4 months that we are aware of, right? Sorry, 3 months. So 4 times when it has been characterized, and depending upon for each and every quarter, there is a demand is known to be 40, 60, 75, 25 boards of manufacture, right? And for first quarter it is 40, second quarter it is 60 need to be manufactured, and third quarter it is 75 need to be manufactured, and fourth quarter that is 25 boards need to be manufactured. Let us schedule this into months category. If January to December and January to December, January to January has been considered, it's okay. Or else, if a financial year has been characterized, we have to calculate from April to next March. So let us consider from April to next March, April 20 to March 21. So April, May, June, July, 4 months. In these 4 months, 40 boards need to be manufactured. That is Q1. And in the from August, September, October, November, and sorry, three months. April, May, June, Q1, July, August, September, Q2, October, November, December, quarter 3. Next again January, February, and March, that is quarter 4. So for 4 quarters, for first quarter it is 40, second quarter it is 60, third quarter 75, and the fourth one is 25 votes. So Sailco is a company, it must determine that how many votes in the sense for each and every quarter, and depending upon the manufacturing, that quarters has been divided, right? And Sailco must meet its demands, so it has to manufacture. Must meet its demands in the sense have to manufacture. So at the beginning of the first quarter, Sailco started with 10 boats in inventory. So it has started at the starting stage, nothing but when you have been considered April, from the April 1st onwards, they have been started for manufacturing 10 boats. So Sailco can produce up to 40 boats. So there is a condition that it has to produce 40 boats for 3 months. That is April, May, June. Within these 3 months, they have to manufacture 40 boats, right? With a regular time labor at $400 per boat. And for each and every boat, there is an $400 of payment. Or additional boats are 450 with overtime labor. So if they OT, we will be calling as an OT, overtime. So if more than 40, if they have been got manufactured, then or that is two different cases. Here we are having two different cases. So if within the time bound, if they manufacture by taking additional time in the working hours, that is, for example, if we are having 10 hours of working time today, and if additionally 2 more hours any worker has been worked out, and he will be paid 450. That is the overtime labor and manufacturing the boats. So boat made in a quarter can be used to meet that quarter's demand. So that 40 need to be completed in the first quarter, that is April, May, June until June, and next one 60 in the second quarter, 75 in the third quarter, and 25 in the fourth quarter. So boats made in quarter can be used to meet that quarter's demand or held in inventory for the next quarter at an extra cost of $20 per boat. So it specifies that in the inventory for the next quarter, if there is any uh, extra cost that they will be spending on each and every boat, that is dollars 20. So what are the constraints that we are having? The given problem is manufacturing of the boats, and it has been subclassified into four different groups, and these four different groups are also given as per the quarterly basis, and how many number of quantity, how many number of boats for each and every quarter of time period, that is for each and every 3 months, how many boats need to be manufactured as per the design criteria given, right? These constraints need to be found out. So moving on to the linear programming technologies, that we are having four different concepts need to be analyzed in the linear programming concept that we are utilizing in operational research methodology. మనకి ఏం తెలుసు అంటే that is first one, proportionality need to be applied initially. Second one, additivity concept need to be applied. Third one, it is if at all there is no any possibility of solving, then we have to move for divisibility concept, and next certainty or sign considerations. So these four different parameters need to be applied in the linear programming technology. So moving on with the similar considerations. First one ఏంటంటే decision variables. Let the time periods be 1, 2, 3, 4. So time periods t is equal to 1, 2, 3, 4 characterized, and let xt be the some unknown words in a quarter, t built in a regular time. Nothing but regular time has been given that 3 months. But let me consider that xt, nothing but అంటే మనం ఓవర్ టైం అనేది చేసాం అనుకోండి, if the extra time ot also given here. So if the xt ot additional time has been taken within that quarter, and the overtime regular time that has been subclassified here, xt and yt, let it be hash as per our convenience. We are taking that variables because that is unknown. And next, if that if t is equal to hash of votes inventory at the end quarter, that additional time will be the demand in quarter t. So there is a greater demand for manufacturing additionally another one more board can be considered in that quarter. So as per the statistics, the proportionality limitation has been applied here, and another additivity concept also applied here. That is additional time bound, and coming to the regular time flexibilities, that is D1, that is 40 votes, nothing but developments or duty of work. D1 40, and within 3 months 40 need to be first quarter 40, second quarter they have to do the work for 60 votes manufacturing, and D3 75, and D4 25. And let us consider that the additional time period, that need to be given with respect to a 10 consideration. So 10 consideration, how we have been analyzed in the sense, Saleco initially at the inventory level it has been started with the 10 boats. So let inventory of that boats will be 10 at an initial stage. So in the first quarter, XT is less than or equal to 40, need to be manufactured 40. So, but what about the buy strategy? So, by the logic that we are having, the inventory concept of T at the time, that is 40 equating, and even let the T will be increased when overtime has been considered. Lest IT is equal to IT minus 1 plus XT plus YT minus delta T. So delta T. So demand met is definitely T is greater than or equal to 0, because 40 we are having manufacturing need to be manufactured, and due to the overtime another will be increasing furtherly. So sign considerations or sign restrictions will be both X and Y values will be definitely greater than 0, definitely greater than 0. So hence, additivity concept also applied, and certainty, moving on to the divisibility and certainty. So moving on to the certainty concept here, we need to minimize the cost. So minimizing the cost subject to three sets of considerations are here. Basically, we need to have the maximum gain, that is Z is equal to the nominally paid amount is 400 for quarter 1 plus 2 x2 plus x3 plus x4, 4 quarters. Simultaneously, if additional time has been obtained, that 450 wages will be paid additionally 50 rupees or $50. So for y1 plus y2 plus y3 plus y4, number of labors, right? Plus additionally 20 of input cost 1 plus cost 2 plus input 3 plus input 4. As per the convenience, upon application of this window reveals the overall minimum cost for manufacturing the entire in the time bound of 4 quarters. The maximum amount that has been spent indeed to manufacture the 40, 60, next 75, and overall 25, 75 and 25. The regular time, how much regular time has been consumed, and how much minimum cost need to be applied, because optimization should be lead to the minimization of cost. And next, inventory then has been considered, and additionally, what inventory need to be taken at each and every quarter. So there is no any inventory considered in each and every quarter, because 40 in the regular time, quarter 2 40 in the regular time, quarter 3 40 in the regular time, quarter 4 25. But the demand is 40, 60, 75, 25. So these are the values in the regular time has been obtained due to the substitution of values in the previous year, right? In this formulation, Z main total cost minimization formulation. So our demand is 40, 60, 75, 25. The regular time